Hello everyone, you're welcome back to my channel, Physics with Curls. In this lesson, we are going to be considering adding up and cancelling out of waves, also called the interference of waves. You're welcome back. Adding up and cancelling out of waves, also known as the interference of waves. A quick review of the physical properties common to all waves. We have reflection, refraction, diffraction, and interference. Reflection. Reflection is a process whereby a wave bounces back to its source when it encounters an obstacle. In this case, we have a wave incident at an angle. As soon as it hits an obstacle at an angle known as the angle of incident to the normal, it reflects back at an angle known as the angle of reflection. Refraction is a process whereby a wave changes speed as well as direction when it moves from one medium to another medium. In this case, we have a wave traveling from a deep water at an angle. As soon as it gets to the shallow water, the speed as well as the direction changed. Notice also the change in wavelength. The crest to crest, distance between crest to crest decreased as soon as it enters the shallow region. Also notice a bit of reflection. Diffraction. Diffraction is a process whereby a wave spreads out when it passes through a narrow gap. And the best spread is achieved when the length of the gap equals the wavelength of the wave. Interference. This is a process whereby two waves combine constructively to produce a higher wave or a larger wave, like what we have in this case, or destructively to produce no wave at all, like what we have in this case. Okay, these are regions where we have no waves at all. In this lesson, we'll be considering the interference of waves, that is the adding up and the cancelling out of waves. Terminologies that we'll be using throughout the lesson: wave in phase or step, waves out of phase or step, superposition or superimposed or superposed, constructive wave, destructive wave, phase difference, wave leading and wave lagging. What does it mean for a wave to be in phase or in step? Waves are in phase when corresponding points align with each other. For instance, when the crest of one wave is in line with the crest of another wave, or when the trough of one wave is in line with the trough of another wave. Let's consider this figure. Whenever the crest of the second wave is in line with the crest of the first wave, we can see they are in phase. But when they are not in line, like in this case now, we see they are out of phase. Waves out of phase or out of step: when corresponding points do not align. For instance, when similar points are not in the same position, maybe crest and trough aligning, such case is what we call wave out of phase or wave out of step. Superposition or superimpose or superposed: when two or more waves overlap to form a new wave, especially when one wave is above the other. Like in this case here, we can say these two waves are superposed or superimposed because one is on the top of the other wave. Constructive wave. When two waves combines to form a bigger wave, here we have wave A and wave B combining in this case. In some cases they combine constructively to form a bigger wave like this. In some cases they combine destructively to form no wave at all. So destructive wave, when two waves cancel out to form zero wave. Phase difference. Phase difference is the difference in position of the two waves. The difference between the crest of one wave and the crest of another wave. We can say it's also the timing difference between the two waves, or the timing gap between two waves. Waves leading. A wave is leading if the crest of the wave is ahead of the crest of the other wave, but lags when the crest is behind the crest of the second wave. Waves can be in phase or in step, or out of phase or out of step when they interact. In phase, if the crest of two waves pass the same point or line at the same time, then they are in phase. Like what we have here, we have a wave A, the crest of this and the crest of AB, they are passing through this point at the same time. And if this happens, they interact or they combine to produce a larger wave like what we have here. So wave A plus wave B gives us the second wave, wave AB, or wave A plus B, okay, which is a larger wave. If the amplitude of wave A is 1 and the amplitude of wave B is 1 meter also, we expect the amplitude of wave C, wave A plus B, to be 2 meter. That is twice the amplitude of one of the waves. Okay, this kind of interaction is what we call a constructive interference. We're going to talk about this again. Wave not in phase or not in step. If the crest of one wave and the trough of another wave passes through a same point at the same time, then the waves are said to be out of phase. Like in this case, the crest and the trough of the second wave, wave B, are passing through the single point at the same time. And when they interact or combine, they form no wave at all. Okay, that is, their resultant wave is zero wave, like what we have here, a straight line. So wave A and wave B are not in phase. The result of combining is a wave with zero amplitude, that is, no wave at all. This kind of combination is what we call a destructive interference. We're also going to talk about it. What happens when waves interact? When waves interact, they add up or cancel out. This is called the interference of wave. It is a general property common to all waves. If the wave add up to produce a bigger wave, then we say they have interacted constructively, or they have constructive interference. If the wave cancel out to produce a small or no wave at all, then we say it is destructive interference. Now, can you identify the constructive and destructive interference in the waves below A and B? Of course, this is constructive interference, and the second one is destructive. We consider this is constructive because the two crests passes through a point at the same time, and we see here we have a bigger wave, which is the resultant wave after combination. More facts about constructive interference. We can draw out more facts from these superimposed waves. Notice that the wavelength of the wave is 8, and the wavelength of the second wave is 8. And notice that the amplitude of the two waves is the same, 2, 2. And the difference in position, or the phase difference of the two waves, is 0. That is the position of the peak of the first wave minus the position of the peak of the second wave. So the peak of the first wave is 2, and the peak of the second wave is 2. So 2 minus 2 is 0. Now we can draw out facts from these two waves that interfered constructively. Some of the facts we can draw out, which is a summary of the condition when two waves interfere constructively, are this: if the two waves are in phase or in step, they interfere constructively. If the difference in position of the wave is 0, that is, the phase difference is 0, that is peak, position of the peak minus position of the second peak. If it's 0, the difference in position, or the phase difference, then they have interfered constructively. If they interfere by a whole number of wavelengths, that is, the ratio of the wavelength of one to the wavelength of the other is a whole number. The wavelength of this is 8, divided by the wavelength of this 8, and then we're getting a whole number. It means they have interfered constructively. If the wavelength of both waves are the same, the wavelength of this wave is 8 and the wavelength of the second one is 8, then they have interfered constructively. Okay? More facts about destructive interference. Now let's check out the two superimposed waves and see facts that we can draw from it. The amplitude of this is 2, and the amplitude of the second one is also 2. The wavelength of this is 8, and the wavelength of the second one is 8. But the phase difference is different. The difference in peak of this and the peak of this. The peak of this one is 2 seconds, while the peak of this is 6 seconds. So the difference in position, or the phase difference, is 6 minus 2, which is 4. And 4 is half of the wavelength of any of the wave. The wavelength is 8 here, the wavelength is 8 here, while 4 is half of the wavelength of any of the waves. Okay? We can summarize that if any of the condition happens, the two waves have interfered destructively. If the two waves are out of step, okay, whenever they are out of step, like what we have here, by half wavelength, they have interfered destructively. This means that the crest of the first wave formed exactly at the time when the trough of the second wave forms. The crest here is formed exactly at the time when the trough here is formed. So this wave is leading, always leading on this second wave. This wave will always form a crest before the second wave will form a crest. Like in this case, crest is formed here before the second wave will form another crest. If the waves have exactly the same amplitude, then destructive interference will take place. Okay, for constructive, the wave don't need to have the same amplitude. The third fact is the first wave is always ahead of the other by half wavelength. That is, the phase difference will always be half of the wavelength of any of the waves. Okay, like what we have here. Now these are facts that determines or shows that a wave have interfered destructively. Waves not in phase but interfere destructively. Now, for waves to interfere destructively, we know that the two waves must not be in phase, and the crest of one wave and the trough of the other must pass through the same point at the same time. That is, the crest directly above the trough. And we know that waves must have the same amplitude, and the phase difference, or the difference in position of the two waves, must be half of the wavelength of the wave. But we have a situation, a different case, where the waves are not in phase but interfered destructively, an isolated case. Okay, now let's have a quick view of this figure here. Now notice that when the crest is not directly above the crest here, maybe on this region or on this region, constructive interference is still taking place, this region and this region. When this crest is above this region or this region, then constructive interference is taking place. The best constructive interference takes place when the peak is above the peak, when this peak here is directly above the peak. These are isolated cases where we have constructive interference. Okay, the waves below are not in phase but interfere constructively. Why? Do you have a reason? The two waves, they are not in phase but interfered constructively. Yes, the wave is different. The phase difference is not half wavelength, rather. Okay, we know that for these waves to interfere destructively, then the phase difference must be half wavelength. Now in this case, the phase difference is not half wavelength, and they interfere by a fraction of a wavelength. These are the reason why these two waves, even though they are not in phase, interfered constructively. This condition must be satisfied. The phase difference must be half wavelength for two waves to interfere destructively. Otherwise, it will interfere constructively. Summary of the difference between a constructive and destructive interference. The constructive interference, the waves are in step or in phase. Destructive interference, the waves are out of step or out of phase. Number 2, all the peaks are in the same place for constructive. For destructive, the peaks of one wave and the trough of the other are in the same place. Number 3, the total sound or the total wave will be louder, that is, the amplitude will be bigger in constructive interference. For destructive, the total sound or the total wave will be quieter or silent, that is, the amplitude will be 0. Number 4, the phase difference should be 0 or slightly above 0. Here, the phase difference should always be half of the wavelength of the wave. Now, the wave must not have the same amplitude in constructive interference, but in destructive interference, the wave must have the same amplitude. Two circular waves, fronts of water wave, interfere constructively where crest meet crest, and destructively where crest meet trough, like what we have here. Okay, so here we have crest meeting crest, the wave for two generated water wave in a ripple tank, and here we have crest meeting trough. That's why we see no wave at all in this region. Interference of sound waves. We need to note that explaining sound wave is simpler when we use an oscilloscope or view the waveforms in an oscilloscope, but in reality, two sound will interfere constructively if the compression of one of the sound wave meets the compression of the other. Okay, hence both compressed wave will form a larger compression, and they will interfere destructively if the compression of one of the wave meets the refraction of the second wave. Good. How is interference of sound useful? One way interference of sound is useful is in the use of headphones. Some headphones produce sounds that cancel out noise. In this case, we have a headphone, a sound from outside source, and a headphone producing a sound that is not in phase with the noise. Okay, that is out of phase with the noise. And the noise and the sound that is not in phase interact destructively, and no sound at all is produced. This is a better version of what I'm trying to explain. So we have an incoming noise, and this headphone produces a sound that is not in phase. These interact to result to no sound at all. This can also be applied in to adjust or fine-tune musical instruments. Interference of sound wave is used to work out whether string in guitar or tunes from piano is playing the correct notes. If you pluck the string of a guitar, you hear a note. If you strike a tuning fork and hold it near the string, you will hear a large note if they are in tune. If it's not in tune, then the two waves will interfere. There will be a time when the waves add up and time when the wave cancel out, producing loud and soft notes. The tuner continues to adjust the string until they hear a large note that does not change. This is how we use interference to adjust and fine-tune musical instrument. Guys, I believe you enjoyed the video. If you want more videos like this, don't forget to subscribe to my channel, and if you love the video, leave a thumb up to indicate, or a comment to indicate that you really enjoyed the video. Have a nice day, and bye bye.